Good morning, good afternoon, good evening. Welcome to this year's first TCC Live. My name is Sudhir Pai, and I am the current chair of the board of directors of the Technology Collaboration Center. It's a voluntary position. Every single board member at the Technology Collaboration Center holds a voluntary position, allowing them to continue what they do during their normal professional life. At my professional life, it's what they call as a triangle. All of my past has been in the oil and gas business with Lamborghini. I then transitioned to commercial aerospace with a very exciting stint at Axiom Space here in Houston, Texas. And right now, I'm the MD for Geoservices at Acteon, a KKR portfolio organization. We have before going ahead, I would like to thank the people who have made this possible today. And I want to give a particular shout out to the wonderful association we have started to develop between the Technology Collaboration Center and Pumps and Pipes. So thank you, Stuart Kaur, Director of Innovation Systems Engineering, Associate Research Professor at the Houston Methodist DeBakey Heart and Vascular Center. And a big thank you to people who have tirelessly worked behind the scenes from the video production team, George Tipsis and Scott Crawford. Moving ahead, the mission of the Technology Collaboration Center has been to be the premier organization to solve the most significant technological challenges with the greatest societal impacts. So it originated in 2014 out of an interest from NASA to go out to the industry to look at what new technologies were available. A Space Act agreement was formed for 5 years, and out of the success, while it ended in 2019, a new one started in 2020, going through till 2025. What better city than Houston, which is the energy capital of the world, and now, as our Mayor Sylvester Turner says, to be the energy transition capital of the world. We have more doctors in 1 square mile called the Texas Medical Center than anywhere else on earth. We are right here in the heart of it, from where we are streaming to you on this call. And then, of course, the aerospace capital of the world, with everything happening around Houston area. Other points: to partner across all of the industries to identify systemic issues and apply inventive resources. Our solutions result in direct economic impacts to partners, communities, society, in general, specifically the 3 regions which I had said: energy, space, and healthcare. And understanding that a few other things, like the fact that we have a very strong port at Houston and some of the other innovative things which are happening on, it's just a matter of time as other industries start to be part of this this initiative and this momentum that we are picking up. Hence, our objective is to be leader in collaborativity, the innovative process of blending creativity and collaboration across diverse industries. I won't go into the details of it. Please feel free to look at our website, techcollaboration.org, where you'll find a lot of information up there, talking about programs and services, talking about who are the members that we have from large industries like KBR, NASA Johnson Space Center, Shell, etc. What you see on the top right are some of the strategic themes for 2022 for this year. These are cross-industry themes, and this is where the Technology Collaboration Center brings value 24/7 throughout the year, wherein we provide programs like this: once a month TCC Live, typically mid-month, TCC News, TCC Connect. We have a very strong internship program. I want to recognize our first intern for this year, Elizabeth Bleckert, who has just joined us, goes by nickname Lisa. She has worked hard to put today's program together. A few other statistics are the interactive workshops, which are done every few months on a theme. And so far, 21 such interactive programs are done, and these are just going to grow. While each program has been outstanding, I just want to highlight one program that we did which had tremendous value, and that was a cross-industry imaging workshop which was done right in the mid, taking the pandemic as an opportunity, wherein imaging experts from 4 different industries, the aerospace represented by our good friend Donald Pettit from NASA, the energy industry, my good friend Dr. John Etchen, geophysical advisor from BP, and then medicine and space medicine with Emmanuel and Juan, one of the outstanding programs which happen. And this is the kind of value which Technology Collaboration Center brings to the industry. I would like to end by saying that this particular introduction that I wanted to give for the Technology Collaboration Center to say that please go ahead and enroll in our future programs. These come out through various channels, particularly our LinkedIn webpage. Please go ahead and register to that. As we go into today's program, please go ahead and join by web. It's going to be a multiple interactive program. Go to polev.com, enter Debeki, and respond to the activity. Alternately, you can join by text. Text Debeki to 37607 and text in your message. And finally, please do not forget to subscribe to the YouTube channel. Thank you very much. And with that, let me hand over to today's moderator for today's event. He is our board member, Mark Perry, and he also represents KBR. Good morning, Mark. Over to you.
Hey, good morning, and thank you. Good introduction. And what I wanted to do to kick off was first introduce Dr. Liz Warren. She's with CASIS, and she is the Senior Program Director for Biological Services. Liz, you can explain that if you want. I won't trouble the audience with that. The reason we're here today is Liz and I have been an acquaintance for a long time, and her wealth of knowledge on what we do, and especially what CASIS does for low Earth orbit, is important. And a talk that she gave to the Human Health Performance Director at NASA triggered the idea that we needed to bring some of this information out publicly. There's quite a bit of effort going on. Liz can touch a little bit on what CASIS does and how to get engaged with them. But what I wanted to also mention were specifically some areas of emphasis that we wanted to talk. And those opportunities present strategic initiatives from a corporate perspective. And the trigger that we wanted to key in on in this particular talk was how do some of those corporate initiatives get fulfilled by low Earth orbit? In my understanding, there's probably a lot of people, especially startups and small companies, that don't understand the opportunity low Earth orbit provides. So we'll touch on that. It's a pretty open forum. We've got the ability to engage with us through the web or by text. So as Sudhir mentioned, please use those. And if Liz touches on anything of interest to you, I would engage immediately, and then let's drive the discussion there. So some of the things we wanted to touch on were low Earth orbit is an accelerated test environment. Liz can give some examples of that. Disease modeling, sustainability, and climate change. From her speech, those are the things that we were going to focus on today, but really this conversation is wide open. So any area of interest, I think we can probably engage the community on. So Liz, let's start with CASIS and what your mission is.
Absolutely. Well, CASIS, the acronym stands for the Center for the Advancement of Science and Space. And in 2005, Congress designated the International Space Station as a U.S. national lab. So first, let me tell you a little bit about our International Space Station. It's been in orbit. It's had people living on it continuously since November of 2000. And it is a football-sized, million-pound, world-class laboratory that is open to all researchers and students as well. We've had people living there, mixed crews. It's an international crew. In and of itself, it's a technological achievement and testament to collaboration to build the International Space Station. It took many years and a lot of work on behalf of a lot of people to assemble this multidisciplinary, amazing laboratory in low Earth orbit. I think there's a little bit of a misconception. Sometimes people think it's only for NASA, but it's an international space station. We've got nations that have built the space station, do research there, and from the perspective of the United States, it is definitely not just for NASA. So NASA tends to use the International Space Station to advance its goals for exploration. For example, learning how to keep astronauts productive, healthy, and safe in space for long periods of time, but also to design and test technologies that can stay in space and be productive and functional for long periods of time. But as I mentioned earlier, in being designated a U.S. national laboratory, what does that mean? Well, to touch on what Sudhir said, national laboratories are large, complex, very unique research facilities that are tasked with solving big problems. And as a U.S. national laboratory, the International Space Station is open to U.S. users of all disciplines. As I mentioned, it's a multidisciplinary laboratory and of all industries. It's not just open to academia, it's open to commercial industry, it's open to students, it's open to investigators who seek to leverage the unique environment on board the International Space Station to benefit life here on Earth. And so that's a pretty broad topic. And so I wanted to highlight a couple of, what makes the International Space Station so unique and why would people want to do research on that facility? And there's three really unique selling propositions that I want to first highlight. The first is sustained microgravity. Microgravity has profound effects on, the first example I'll give is living systems. Everything from microbes to cells to whole organisms to humans, as I mentioned earlier. Without the force of gravity continually acting on living systems, some pretty interesting changes occur. And probably most of the audience is familiar with some of those. We've heard that astronauts lose bone and muscle in space. And I'll touch on that a little bit later when I discuss microgravity as a model for disease. And so a lot of those changes that happen in astronauts, it also includes cardiovascular deconditioning, immune dysfunction. A lot of those changes appear similar to diseases here on Earth and the processes involved in disease. They may not be exactly the same things. The bone loss that we see in astronauts is largely disuse, as opposed to bone loss in our elderly population here, which is probably a combination of disuse, but also some disease processes. But it gives us a really unique insight into what happens, because normally we're taking the most healthy people and individuals on the planet, we put them in an environment where their body starts to decondition very rapidly, and when they return to Earth, those processes reverse. So it offers a really unique opportunity to investigate what is happening at the functional and molecular and cellular and genetic level that is happening there. Microgravity also it has profound effects on physical systems. So again, without the force of gravity, forces like capillary flow and the forces of surface tension tend to be a little more dominant. So fluids behave differently. Combustion is differently. There's no convection, so hot air doesn't rise, cold air doesn't sink, no buoyancy-driven convection, no sedimentation. So it becomes a very interesting environment to do materials research, combustion research, advanced materials, ceramics. We have got facilities to smelt metals. We've got furnaces. We've got combustion facilities. So a lot of physical science, material science can occur on the space station as well. And then the second unique selling proposition is the research facilities outside of the space station. It's an extremely extreme environment, from very large temperature swings that happen very, very quickly, about 250 degrees Fahrenheit to minus 250 degrees Fahrenheit. There's also, it's a vacuum, so when you put materials outside of the space station, it's, as I mentioned earlier, kind of an accelerated testing environment for materials. And then last but not least, the space station can be used as a vantage point to study our own Earth, or the cosmos as well, but it's an environment where we can put sensors outside of the space station or inside the space station to monitor what is happening on our own Earth. And so those three unique selling propositions are really what brings people to use the International Space Station. And again, as I highlighted earlier, as a national laboratory, this facility is open to users not only in academia, not only in industry, commercial industry, as well as students. And so I think with that kind of introduction, I'll kick it back over to Mark, and we can start getting into some of the questions and some of the specific examples.
Yeah, I think first let's touch on, you and I, even this morning, every time we have these conversations, we kind of think about new angles to talk about this. This morning we were talking about when you mention research, let's define that a little bit. It doesn't have to be the traditional piece of it, right? There are proofs of concepts that falls underneath a research umbrella. And even if you're going to do a proof of concept or mature prototype, those things are all fair game. Would you think that's appropriate?
Yeah, absolutely. So there are research opportunities, like I mentioned, and you may have a very mature concept that you want to do a research experiment on, but even if you just want to test a technology, say you want to possibly raise TRL level, we've got solicitations and research announcements specifically for that purpose. And that is a good segue to, all right, so I've mentioned that this facility is open to all kinds of users. How does someone actually get involved, and how does someone actually get their research on board the International Space Station? So as I mentioned earlier, of course, there's two broad categories. People can apply to NASA research announcements. Those tend to be pretty specific to advance NASA's exploration goals. Or you can visit our website. It is issnationallab.org, issnationallab.org, and there's a research announcement page. And you can find a schedule of all of FY22 research announcements, and they are broad. We've got research announcements on technology development, like I mentioned earlier. If you're potentially interested in just testing a technology, raising your TRL level of a product, improving a product. We've got capabilities to do tissue engineering and regenerative medicine. Those are generally co-sponsored through the National Science Foundation, NSF. As I mentioned, in materials, we've got advanced materials and transport phenomena solicitations, also co-sponsored with the NSF. We've also got some interesting opportunities at the accelerator level. Coming soon, Mass Challenge is an annual program that we've co-sponsored with Boeing Corporation, in which we are able to bring in startup, small biotech firms, small companies that want to attract some venture capital, fly their experiment to the International Space Station, learn a lot. And one of the other things that we were talking about earlier, Mark, is the ability to iterate. So sometimes we get a little caught up in thinking about a space experiment and wanting to have end-to-end success. We're also open to the idea of people that want to fly something, bring it back home, learn, iterate their experiment, and fly again.
So it doesn't have to be fully cooked, right?
Doesn't have to be fully cooked.
Yeah, the concept can be there, the idea can be there.
Absolutely.
So this test bed is generated for that.
Yeah.
So one quick example we can touch on. So you talked about the accelerated test environment. So you have an example that CASIS sponsored research or proof of concept. So materials testing, right? So a major car manufacturer. So that's a good example, I think, that we can start with, where someone who you wouldn't normally associate NASA research with came and saw the opportunity there. So touch on that one. I like that one.
Yeah, there's so many examples like that where some pretty non-traditional users who previously were unaware that they could use the International Space Station found out about this capability. And so the car company, Lamborghini, they tend to test a lot of their materials out in the desert. They want a lot of temperature cycling. They want an extreme environment. So they actually flew some materials out on the outside of the space station, that extreme environment that I described. And I think they said something like they were able to, in 6 months outside the space station, accelerate their testing and shorten the actual test time pretty greatly. And so that's one of my favorite non-traditional users that wanted to test something outside the space station in an extreme environment.
So one of the questions that we have are, can you touch on specific projects and companies who have utilized LEO and space station? So I think we've got a couple of examples, right? So we talked about those categories. So Lamborghini would be one. Do you want to expand on that, or do you want to run down this list?
Yeah, let's talk about some other examples. One of my very favorite, and it has to do with the medical facility that we're in today. Merck Pharmaceutical Company has flown a number of investigations to the space station. One recently, there's a very commonly prescribed cancer drug out there called Keytruda, and it's FDA approved. It is out in use right now. There's some factors about it that involve coming to the clinic and getting an infusion over several hours of this highly effective cancer drug. Keytruda actually Merck Pharmaceuticals flew Keytruda or the preliminary ingredients to the International Space Station and found that they could actually change the formulation, change the crystalline structure of the actual pharmaceutical, make it smaller. The crystals were actually smaller and more uniform, and eventually that may find its way to the patient through an injection that they can give themselves at home rather than come to the clinic for an infusion. So in that case, it's a improvement of a product. So it's not even necessarily inventing or coming up with a new product, but it's an opportunity to make an improvement on an existing product. Another example kind of along those lines is Procter & Gamble. They've flown a number of common consumer products to the International Space Station. Again, so a shelf life of something like a fabric softener. If you let that sit on your shelf for a very long time, it'll start to separate, maybe get a little clumpy. They were interested in learning more about how all the little colloids are fluids with particles within them. Are they able to increase the shelf life by improving the colloid distribution or even the shape of those particles? And Procter & Gamble's got a couple of patents that they've obtained by flying research to the International Space Station. You had mentioned, or I think maybe Sudhir, you had on one of your slides, water conservation. Mm-hmm. Delta Faucet flew an experiment to the International Space Station looking at droplet formation and how could they improve perhaps a shower head to give the end user, the consumer, a very satisfying feeling of a shower without using as much water. So again, there's some very creative uses, and sometimes it's hard to even imagine what is possible. And that's one of the benefits of talking to researchers that at the ISS National Lab, at CASIS, or at NASA. Sometimes we can help you think through some of the issues that are affecting your company. And in fact, one of our favorite questions to ask people as they're considering using the International Space Station is, what are your pinch points? What is challenging for you? What keeps you up at night? And sometimes that just gets the conversation rolling. Another example that I wanted to bring up, and something that started a conversation with a question like that, well, what kinds of challenges do you have? We were talking to Target Corporation and asked them, well, what keeps you up at night? And someone from Target Corporation mentioned, we sell a lot of cotton t-shirts. And in the production of a cotton t-shirt, about 700 gallons of water are used. And that's from growing the cotton to processing the cotton to making the t-shirt, cleaning the t-shirt before it is sold. And Target wondered, is there a way that we can reduce that water use to make a cotton t-shirt? And so Target Corporation with CASIS sponsored a sustainability type of a solicitation of a research announcement. And we got several people that were interested in helping to solve that problem. Everything from testing different cultivars of cotton plants, putting the cotton plants in a very stressful environment, seeing if we can change the genetics of cotton to make them more drought resistant, and everything from that all the way to remote sensing, using the space station as a platform to study the Earth and understanding, are there better uses of the land where cotton is grown. And so those are a couple of examples of large companies that have used the International Space Station to benefit life on Earth.
Yeah, let me put you on the spot. I think you have one more. So there's a question that came in online about sustainability. So you've touched on a couple of those, but another one you have is Estee Lauder. So and some of these you can find publicly. So we can provide posts or links to these things through our social media sites, so people can go and research those. But touch on that one, please.
Yeah, absolutely. So we've got an active research announcement with Estee Lauder, again, in the topic of sustainability. And in this case, Estee Lauder is interested in understanding how can we move beyond plastics. That doesn't mean replacing plastics, but it maybe means, can we use plastics that are more easily biodegradable? Or can we use plastics that are not as prevalent in the ocean? Or is there something that we can do in the manufacture of plastics to reduce footprint? And that's an active research announcement. I think a lot of excitement has been built up around that. And in fact, later this month, if you go to the issnationallab.org website, you'll be able to watch the challenge, almost like a little bit of a Shark Tank competition, where the different proposers are going to pitch their idea to Estee Lauder and to CASIS and see who gets to advance to the next step.
Let me ask this question. So someone might be wondering what the life cycle for something like this is, from the cradle to grave. So do you support unsolicited engagements? Can someone come and knock on your door and say, hey, I want to do this? And then how much time does it take from cradle to grave? Now, I know complexity and mission cycles and opportunities on ISS can cause a lot of variation in that, but touch on maybe one of the quickest concepts to implementations that you've seen.
Yeah, absolutely. And Mark, you're absolutely right. Sometimes it takes, the more complex experiments may take a little bit longer to get through the entire life cycle, including iteration and maybe even flying again. But in general, you're looking at about 18 months from proposing your idea, getting through our system, and getting to flight. You had also mentioned, can anyone, do we accept unsolicited proposals? Right now, we're going to point you to our website, to our solicitations. We've got, like I mentioned, some pretty broad solicitations that are open year-round. There are some possibilities if someone comes up with their own idea, because we certainly can't think of all the most creative ideas. So we're open to hearing your ideas and seeing if it fits into either our open solicitations, or if you don't require any funding, and you bring all of your own funding, that may be another mechanism for you.
So we've got another question. I can't touch on this one, but maybe you can. This might be your first hard one of the day. Do they test for COVID on ISS? I have not been engaged to know what the protocols are for that. So good luck with this one.
And great question. Thank you.
And it's very applicable, right? I think all of us have experienced some testing at home, or at least some testing at a COVID testing center. We don't test for COVID on the ISS currently, because we're very careful about pre-launch quarantining of our crew members. And there's a lot of testing that happens before launch. We certainly don't want to bring COVID to the International Space Station. And so we've done pre-launch testing, and then anyone who's going to come in contact with astronauts after flight, I believe, is probably going to be tested for COVID as well. I mentioned that the immune system is dysfunctional in our astronauts while they're in space. We don't fully understand all of what is happening there. As I mentioned earlier, kind of an interesting disease model to look at. So it does bring up an interesting question, though, and what else happens to our astronauts while they're in space? And Mark, you and I worked in NASA's Human Research Program, and there's another example of disease modeling that I wanted to bring up. So I mentioned cardiovascular deconditioning, I mentioned immune dysfunction, I mentioned bone loss and muscle loss. The NIH is pretty interested in all of those changes because, again, we're taking very healthy human beings, we're putting them in an environment in which their bodies decondition fairly rapidly. But then when they get back to Earth, most of those changes reverse and they get back to their healthy state. And it all happens very rapidly. And that is very interesting to the NIH. And we've done some investigations sponsored by the NIH in organs on chip, tissue on chip technologies. These are small microphysiological systems, maybe the size of a thumb drive. They kind of look like a microchip in that they've got all these little channels within a biocompatible plastic. And instead of conduits or chips, there are actually fluid channels in which we line those fluid channels with cells, human cells, and the tissue chip technologies, they replicate or recreate human physiological responses extremely well. And so these microphysiological systems or tissue chips can be used to model diseases and test new pharmaceuticals. And so we're sending those to the International Space Station, validating that first they react physiologically like an astronaut, and then the next step for a lot of these is testing a pharmaceutical. And so we've been doing several investigations in this regard, and it's an extremely exciting field. And so watch out for some new results coming from those investigations.
Fascinating discussion, Liz. I'm just touching on a couple of things you had mentioned earlier. As an engineer growing up, we've always been moving towards using microgravity to advantages on Earth. Here we are seeing a very different perspective, how lack of gravity or less gravity up in space can be used for advantages. So I kind of had two questions, one for using that for sustainable life on Earth and another up in space. Let me touch the first one, and it's a pinch point. It's something which keeps me awake at night, and that is two of the 7 most important women in my life, other than our daughter, my wife, my sisters, my mom, grandmother, and great-grandmother. They suffered from vision issues. My mom and my great-grandmother had cataract, and it was, I could see what they went through that time. Tell us a little bit more about how microgravity can be used for giving a much better life on Earth, understanding that 4 million Americans every year, according to statistics, suffer from some kind of blindness due to preconditions. Can you touch a little bit on that, Liz?
Absolutely, and this brings up one of my favorite analogies when I'm talking to other researchers who don't quite see why they might want to send their experiment to the International Space Station. One of my favorite analogies is to say, everything, all the science you've ever done in your life has had at least one constant variable, and that is gravity. And if you remove that variable, if you change gravity, it's like looking at whatever system you study with a brand new lens of discovery. And so to bring that back to vision, there's actually some really important vision research that is happening on board the International Space Station. Something I didn't mention earlier, astronauts, we've recently discovered, well, maybe not so recent anymore, that there's some unusual vision changes, decrements that are occurring in astronauts, and we're not entirely sure what is causing those changes. But another researcher here on Earth, Nicole Wagner, she's president, CEO, and founder of a small biotech firm called Vision. And this combines a lot of research topics, so it's a great example. Her company manufactures artificial implantable retinas. And these retinas are made from basically a biological layer by layer manufacturing process on a biocompatible plastic. They can be implanted in the eye and provide some really excellent resolution and solutions for people with vision loss from macular degeneration or retinitis pigmentosa. She flew an experiment to the International Space Station asking the question, if I manufacture these artificial implantable retinas in space, are they going to be any different than what I can manufacture here on Earth? And it turns out that in her layer by layer manufacturing process here on Earth, little imperfections can happen due to sedimentations, heavier particles settling one way or another, and maybe not making the most uniform retina, artificial retina. And so she did this experiment in space and found some really promising results that her artificial retinas could be manufactured in microgravity and turn out more perfect, more ideal. So she's continuing that research, iterating, flying a number of different investigations, improving her process each time to see if one day she may be able to actually manufacture these retinas on board the International Space Station. And that's pretty exciting. And of course, it takes a little while to get this all done and to make something that can be actually FDA approved to be implanted in people. So there's a lot of challenges ahead, but it's an extremely exciting possibility.
Wonderful. My family who is watching this show today from the comfort of their home are going to feel fairly relieved that there is light at the end of the tunnel, right?
There is.
Yeah. And just a follow-up question related to going out into space with the opening up of the economy, with opening up of the commercial aerospace, etc., and the strong interest. What I heard is, 1,000 millennials who were kind of asked this question that you have a chance to go to Mars. There is a possibility that it's a one-way ticket. Almost every single one raised their hand up saying, what a wonderful opportunity, understanding that over this period of time, research will be done related to make sure that it's a safe round trip. What have you seen work being done in the low Earth orbit in general, but particularly at the space station or somewhere else, looking to make sure that it's a safe trip going up there and coming for sustainable life in space?
Oh gosh, there's so many things. The first ones that come to mind are, in order to live sustainably in space, we've got to be able to have technologies, life support systems that are robust enough to last the journey and be something that are dependable. And so a lot of the research on the International Space Station is in that regard. Human health, of course, and behavior and performance is another really big topic. And we're making tremendous headway in that regard. Mark Van de Hei, who's in space right now, is a U.S. astronaut, and he has been in space for almost a year. I don't want to quote the number because I might get it wrong, but we're learning a tremendous amount of how to keep people alive and healthy in space. We've made tremendous headway in that, again, from the NASA's Human Research Program that Mark and I worked on. But also, what about food? And what about medicines? There's a lot of really interesting research happening in how do we get our crew members, our astronauts, anyone who wants to go to space, how are we going to be able to provide them with nutritious, palatable food that is going to be able to maintain its palatability and nutritional value for really, really long periods of time. And medicines is another interesting question. In humans, the pharmacodynamics and pharmacokinetics is a little bit different too. We're not quite sure exactly what's happening there, but if I take an Advil today, and if I live in space tomorrow and I take the same Advil, it might affect me a little bit differently. And so we want to understand that, but also, a trip to Mars is going to be a pretty long time. And if someone wants to live there indefinitely, if it's a one-way trip, we're going to have to be able to provide pharmaceuticals that are effective and last for a really long time. We're probably going to have to manufacture a lot of our own food, manufacture a lot of our own pharmaceuticals. And so we're interested in all those areas. If people have creative, innovative solutions on how to do that, there's concepts out there about 3D printing food, 3D printing pharmaceuticals. There are 3D printers on the space station, of course. There's also even a biofabrication facility in which we are bioprinting, well, I just gave it away. We're printing biological tissues. If you're injured, maybe not necessarily growing your own kidney, although that's not out of the question one day, but what if you have a tissue injury? Is it possible to print yourself some tissue to replace a burn or a cut? So there's a lot of questions, but there's a lot of really promising research that is helping us get there.
So you mean one of my favorite foods, the chicken tikka masala, could be had in space?
Absolutely, absolutely. It sounds good, actually.
Great to know. Mark, over to you.
Yeah, sure. Let me go back to a couple of questions that I see online, and we're starting to stack them up. So the two that we see on our teleprompters here, let me see if I can smash those together. So they talk about geopolitical elements exist for low Earth orbit. So how do you engage with equivalent entities around the world? But there's also other entities within NASA, right? And you mentioned the Human Research Program. So can you touch on CASIS's role in collaboration? And then as a follow-up, well, I'll save that one.
Okay.
Let's touch that one. That could be a mouthful, just that one by itself.
Right, absolutely. Well, we're a very collaborative. Well, the International Space Station, as I mentioned, is an incredible opportunity for collaborative and cooperative research and technology development. And I think from a geopolitical aspect, what we're seeing in orbit is continued collaboration and cooperation, and that keeps it a little bit separate. And the space station is only about 250 miles away from Earth, but from that perspective, you don't see borders, and you don't see countries. You just see large land masses, and we're all on this big planet together. So I think that's a pretty unique perspective that people can get from the space station, and anyone who travels to space.
So certainly we're starting to see plenty of collaboration expand, right? For CASIS, is your mission U.S. first?
Yeah, we have, because we were designated by Congress to manage a U.S. national laboratory, there are restrictions for how researchers can come to the International Space Station through us. They do have to be U.S. persons and U.S. entities. And there are mechanisms to not necessarily to work around that, but we are open to further collaborations, but that is our primary goal.
So specifically when you talk about collaborations between Human Research Program and CASIS, for the most part, they have their own sponsorship paths. We have done collaborations in the past, but for the most part, they focused on their own initiatives. Is that fair?
This is fair. We actually at CASIS don't do a lot of human research. That really is in the realm of NASA. And so there really is kind of a dividing point. Anytime someone says, hey, I'm really interested in doing research on the space station, can you help me? One of those first questions is your research more geared toward keeping astronauts healthy and productive in space, or testing technologies needed for space and NASA's missions, or is your interest to leverage the space station to bring a benefit to life on Earth? And that really is the dividing question. And so for people who are interested in human health and need to study something on astronauts, that is generally going to be a NASA-sponsored investigation, and NASA handles the institutional review, the consent, and the crew time, et cetera. But if someone is interested in something that is geared more toward increasing or benefiting life on Earth, they may not necessarily need to be using astronauts in that case. And so we do have some delineation there, and I would encourage, if people are really truly interested in understanding astronaut health, that they go toward the NASA mechanisms to fly.
So one of the follow-up questions there, so Miss Jeannie Bop, she cheated, she texted me a question here, near and dear to my heart because she introduced me to TCC, so, and I know you're fond of her as well. So she asked for the improvements that might be underway to quickly fly investigations, which goes along with a lot of the other things. So this is beginning to be a little bit competitive space, right? So we've got other low Earth orbit initiatives in work, some in partnership with NASA. So ISS is not the only game in town, and in the future certainly it won't be. And then not to mention that we've got other research platforms planned in the future. So we're talking about low Earth orbit today, but future would be Gateway program around the moon, which brings a whole new set of research initiatives. So let's talk about improvements that you've seen in streamlining. You mentioned the 18-month process, but not everyone will take 18 months. And then how are we going to address some of the commercial congestion that we have in the short term? And then Sudhir, you can touch on some of these things from your background as well.
Absolutely. The environment is fairly competitive. We've got the use of the International Space Station until 2030. So even though it's competitive, get in line now. And if you're interested, definitely, get in touch now. But we've got many years left to do research on the International Space Station. There are follow-on low Earth orbit research platforms in work, so that we're able to maintain a research environment on the in low Earth orbit. So that's very encouraging. There's a thriving economy developing in low Earth orbit. Many different companies are involved, and many different users. NASA is just considered one of many users of the low Earth orbit research platforms. So that's pretty exciting, and it's the exciting part there is that really anyone who has an interest and desire to do research in low Earth orbit, there's multiple mechanisms to do it. And so that's like the take-home message that I really want people to know. It's if people are intrigued or even slightly interested, go ahead and get in touch, engage with us. You can get in touch with the TCC, you can get in touch with NASA, you can get in touch with CASIS at the issnationallab.org. And there's a multitude of ways to get your experiment to the space station. And most of those entities are able to help people figure out exactly what they want to do. Because sometimes it's a little challenging if this is something that you're not used to thinking about. If you're an oil and gas company, and you want to study the way viscous fluids may be moving in pipes, why would you want to do research in space? Well, I'll tell you, you can learn some very fundamental aspects of fluids, improve your modeling, and apply that to Earth. So it's not just doing space for research in space, or not just doing research there, but it's again, learning things that you can apply here on Earth. That is really the important part of the message that I really want to drive home.
Wonderful. Just piggyback on that, we heard an announcement recently that the new NASA chief scientist has an additional job function related to something which is extremely close to my heart, which is climate change. And so maybe can you touch a little bit more about how Leo, and you did touch a little bit on remote monitoring, etc., happening in space. How, again, can research and analysis which is done up there directly impact, for a better sustainable life on Earth? We hear so much about, Sentinel-6 going up there and finding out the rise and fall of the water levels in the oceans. Methane sat is supposed to go up later this year, looking at methane emissions around the world. I'm sure this is another topic which is close to your heart, Liz. Tell us a bit more. Can you throw a little bit more light in that direction?
Absolutely, and this falls largely, NASA as an agency has tremendous resources in low Earth orbit that are directed toward studying life and sustainable life here on Earth. Really some tremendous sensors and technologies that are aimed at studying our own planet, and all of that data is available. There's investigations. Some of them are satellites of themselves, but a lot of these sensors are on the outside of the space station. The space station covers through its orbit about 90% of the populated regions of our planet, every day. And so some of these sensor technologies that I mentioned are studying, oceans, the canopy, studying plants, studying vegetation, studying heat maps, and all of that data, all of those resources are hyperspectral imaging, and they're all available publicly. So anyone can go and mine that data and learn a lot, and it's not just of the United States, it's all over the world. And so there's some tremendous resources available that publicly. You don't have to apply for a grant, you don't have to apply for anything, you just have to go and find this data, mine this data. It's all publicly available on NASA websites, and that is tremendous. And it is exciting that we've got climate change scientist at the helm at NASA, and it's kind of brings light to the importance of understanding and studying our own planet.
There are a couple of more questions. I know we have about 9 minutes left on the broadcast here, so let me try to touch on one. We've mentioned a little bit about the commercial space opportunities, so business opportunities for research and business, and to support the business opportunities for corporations. So obviously there's places there to sustain that demand, but there are also other upgrades to the ISS, right? So for the most part, ISS is built out, but there are commercial interests who are using that as a springboard, and that will lead to additional upgrades to the ISS that also feed commercial initiatives. So I think it's important to mention that too. Sudhir, what do you want to do? There's some other details that we can cover here, or did you want to close out? There's one other question on there about astronauts vaccinated for COVID, and that's probably a no-go zone for us since it's medically sensitive.
Yeah, probably can't talk about that one.
So even if we knew, right? Not that we do know. I don't know. So
listen, fascinating discussion on here. Yeah, let me ask that one final question to you. What's next for Liz Warren?
Oh gosh. Next for Liz Warren is I'm going to continue to help people get their research to low Earth orbit. This is something that I've been passionate about since I was a little kid. I want to go to space one day. Hopefully that's in the cards. We'll see.
Hopefully everybody is hearing this on this broadcast.
But really, my passion is helping people understand how they might benefit from doing research in space. Low Earth orbit is an amazing place to do research. There's next steps further out. We're going back to the moon. We're going on to Mars, and the world today. I also want to address, for people who've got young kids out there, and staying interested in STEM, staying curious, asking questions. This is how we make ourselves better and how we improve our lives here on Earth. And there's a very broad and wide open field out there, and that's really exciting to me, being a part of this.
Wonderful. On that note, Mark, Liz, thank you for this wonderful fireside chat today. We call TCC Live. Stuart, George, Scott, behind the scenes, thank you for coordinating this today's chat. We are super excited about our relationship of the Technology Collaboration Center with Pumps and Pipes. Please look out, like I mentioned, on our communications on future TCC Lives and workshops which are going to come up. Again, if you have a suggestion about a topic, at the end of the day, a large reason why we are all here is to make sure we share up-to-date ideas, also through the questions which come up, just like how Liz brought up her perspective today and CASIS's perspective. Feel free to reach out to us on any new topics you might need. They are far-ranging, as is the theme of TCC, across multi-industry and how cross-industry we can get together. So with that, again, thank you so much, and we look forward to seeing you on the next edition of TCC Live in the upcoming months. Thank you, and have a lovely and safe day today.